So we have these three particles. I think it's helpful, we just talked very, very briefly about how we figured those out, that they exist. That's not going to be, I'm not going to test you on it. But you do need to know what these particles are. There are electrons. The electrons are found outside the nucleus, and they have a negative charge. Protons are in the nucleus. They have a positive charge. Their positive charge is the same in size to the negative charge on the electron. So if you have one electron and one proton, their charges add up to 0. And then we also have the neutrons. And neutrons are also inside the nucleus. They have no charge, and they have the same mass as a proton. I'm not really sure why they have the periodic table there. Yeah, I can't remember what's coming. Oh, there. Okay. I want to look at this table, and then we'll go back to the other stuff. Because sometimes you just need kind of an overview. So these are, we call these subatomic particles because they are particles that are smaller than an atom. These are the particles that are inside the atom. And you need to know these guys. You need to know their names. Electrons, protons, and neutrons. Their relative mass is what we get when we say, well, if the electron had a mass of 1, no unit, just we're going to say that's 1, then the proton would be 1,836. The neutron would weigh 1,839. So that's pretty close to 2,000. So protons and neutrons are about 2,000 times larger in mass than an electron is. And so what we often do is we think of the mass of the electron as being essentially 0, and this being 1, and this being 1. And so we say, well, the neutron and the proton are about the same mass, and the electron is so much smaller that most of the time we can just ignore its mass. It does have mass, but it's so small compared to everything else that we can ignore it most of the time. It'd be like, the semi-truck full of ping pong balls. The individual ping pong ball weighs so little in comparison to the truck that you throw one more ping pong ball on and you can just ignore that, right? That's how small the electrons are. Relative charges, the electron is -1, the proton is +1, the neutron has no charge. So you need to know which one's negative, which one's positive, and which one's neutral. The proton is positive. They both start with P. The neutron is neutral. Okay? So that leaves the electron to be the negative one. The electron is the little tiny one, and the proton and the neutron are large in comparison. Let's go back to those other slides. And we did that one. So the nucleus. The nucleus is where the protons and the neutrons are. Those are the largest particles that are inside the atom. And those are clustered together in the nucleus. The nucleus is very small compared to the overall size of the atom. The nucleus is incredibly dense. Almost all of the atom's mass is found in the nucleus, which is also very small for the whole size. And then you've got a few little electrons. So just to give you an idea of the size, if the nucleus was the size of a green pea, and you put that on the 50-yard line of a football field, the edge of a typical atom would be at each goal line. So you've got a green pea on the 50-yard line, and then you've got a sphere that's as wide as the football field. And in there are a few little tiny electrons that are much smaller than a pea. And so atoms are actually made up of mostly empty space. It's just kind of crazy to think about. How dense is the nucleus? On a printed page, like in your book, or if you printed out the notes, period. You know how big a period is. It's a little tiny dot. If, we can't do this, but if you were able to just take nuclei and make a ball the size of a period, it would weigh like 10 million tons. Can you imagine that? It's very hard to imagine. And so like this table feels pretty solid, right? Looks like it's solid. It's mostly empty space. Very, very, you can really make your brain hurt thinking about stuff like that. Why do different atoms have different chemical properties? Let's just think of something. Oxygen. Oxygen's an element composed of oxygen atoms, and oxygen burns, doesn't it? It's flammable. How about something like copper or lead? Does lead burn? No, it has different chemical properties than oxygen. Why? Well, it has to do with those electrons. The chemical behavior of atoms arises from the electrons. The nucleus is in the center and the electrons are around it. When an atom interacts with another atom, it's the electrons that are interacting. So when atoms combine to form molecules, one way to think of it is that the electrons intermingle. They interact with each other. It's the electrons. The nuclei don't have anything to do with it. It's all about the electrons. So it's actually the number of electrons that really determines the chemical behavior of an atom.